Hello students, welcome back to computer organization classes. So the next topic from second module is interrupts. Interrupt. The general meaning of interrupt is disturbance. So here interrupt refers to a signal, hardware signal, okay, or a signal generated by a device. So which indicating the processor to perform certain tasks. That's it. Okay, like a keystroke or certain kinds of signals at all. So there are many situations where other tasks can be performed while waiting for an input-output device to become ready. A hardware signal which is called as interrupt, as I told you earlier. So this will alert the processor when IO device becomes ready. The interrupt signal is sent to the interrupt request line. So there will be a dedicated uh, channel like control bus, okay, is used for transferring the signal interrupt here it is called as interrupt request line hence or a bus, okay. It is through that bus signal is sent to the processor from the uh, peripheral. So processor is considered as the brain of the computer. So it will analyze the meaning of the signal and performs the appropriate task. The processor can be performing its own task without the need to continuously check the IO device. Okay, the routine executed in response to the interrupt request. So obvious, this is obvious. So when an interrupt is generated, this indicates the processor that some additional task or special task should be performed. So performing of task is done by executing certain code, isn't it? So by executing certain program, here it is called as interrupt service routine, where routine is nothing but a module. Earlier we have discussed about subroutines, right? Routine means module. So here, since this is also a subroutine, but which performs the interrupt handling, right? So hence it is called as interrupt service routines or ISR. So the processor will recognize a signal called as the normal interrupt request is marked with label INTR and acknowledgement is marked with INTA. So what is INTA then? Once the interrupt request is recognized by the processor, it can send an acknowledgement saying, yes, I have received your request, I will perform certain task, right? So such type of indication can be given by processor towards the particular device. So that can be done with the help of the interrupt that is marked as the interrupt acknowledgement, okay, INTA. So here is the example for in transfer of control between the subroutine, similar to subroutine only, we call it as interrupt service routine. That's it. So there is a compute routine and display or print routine, okay. uh, Line number is sequential execution, you have to follow line number 1 2 and so on. At line number I, the interrupt occurs, so print command is executed, say. So or display routine is called, in other words you can say display routine is called. So just to recall the subroutine linkage earlier what we have discussed, so it is exactly similar to that. So transfer of control, you can see, check the arrow mark is shifted towards the display routine. All the instructions from display routine, this is a subroutine now, right? We call it here it as interrupt service routine. That's it. It will be executed line by line, one after the other. All the n number of lines will be executed and control will be returned back to the next line of the main function. What is the main function? Compute routine is the main function here. So I plus 1th line it will be returned to, right? You can see the execution step here. So the processor first completes the execution of ith instruction, as you are aware of. Then what will happen? Processor loads the program counter value with the address of the first instruction of the interrupt service routine, because I plus 1 value should not be stored because of the execution of the interrupt or ISR, interrupt service routine. So address value of program counter will be updated. Just recall the things what we have discussed earlier in the previous module, right? So service routine and subroutine. Then what is the difference? Question comes. So a subroutine performs a function. A subroutine performs a function required by the program from which it is called, and ISR may not have anything in common with program being executed at the time of interrupt request is received. Okay, some of the built-in interrupt handlers are available. So um, necessary task will be automatically performed once the interrupt request line is asserted. But here for subroutine, no such request lines or explicit kind of signals available. No such explicit signals will be available, but instead what happens? So you make explicit call with the help of the call instruction, right? Call instruction is used for calling the subroutine. So subroutine is just a linkage of two or more functions related to each other, and interrupt is a mechanism for coordinating the IO transfer. So you cannot say it is the linkage of two or more, but an interrupt, hence it is called as mechanism for coordinating the IO transfer. Interrupt itself is a mechanism for coordinating the IO transfer. IO transfer in the sense IO stands for the hardware device, isn't it? So a way to deal with hardware device, a way to deal with hardware devices through program, that is done with the help of the interrupt, right? So here uh, software interface is used to handle the mechanisms of or trigger or control the mechanisms of the hardware, that is done with the help of the interrupt. Okay, please remember. Next concept is of course interrupt hardware. So interrupt hardware, this is what the general configuration of the interrupt hardware. So it looks like each devices looks like a switch here. Okay, there is a common line, request line, interrupt request line, which is marked as INTR bar. Why INTR bar is used? See, on top bar it is used because it is active low signal, which indicates it is an active low signal. Then left hand side it is connected to the processor, and right hand side you can see, and right hand side it is connected to the power supply. That's it. Okay. So the circuit is completed. So each device, IO device, especially the interrupt is raised by hardware unit. Keyboard is a hardware unit, mouse is a hardware unit, right? Monitor is a hardware unit, or printer is a hardware unit, right? So these are all the examples for hardware devices or peripherals in general, you can say. So each device is marked with in as a box. Okay, INTR1, INTR2 and INTRN are the n number of devices connected through a common channel to the processor. So all the interrupt requests are carried through a common channel. Then each device, and please remember, each device will be having, each peripheral will be having its own address value. So through its identity or address value, the device will be identified. So what happens is, initially all the switches are open. You can see there is a disconnection, you can see, right? Switches are not connected, switches are open. If any switch is closed, then circuit will be complete. Once the circuit is completed, what happens? Interrupt request will be asserted. So that interrupt request will be asserted, that will pass through the uh, INTR bar line, and it will move to the towards the processor. So processor will understand later on from which device this request has been generated based on the device ID. Okay. Similarly, in the next interval, if second device is raising the interrupt, how interrupt will be raised? Just by closing the circuit. If you just close the switch, so a keystroke which may cause of closing a switch. Okay, so what happens? Circuit will be completed, so device triggers, processor will be knowing this triggering. Okay, and what happens? Necessary action will be taken by the processor. Please go through all these explanations. Okay. If you have any doubt, please ask. Next comes is the enabling and disabling of interrupt. So all computers fundamentally should be able to enable and disable the interrupt. Since interrupt is a hardware device, you can turn off them, right? So in that case, all the devices, all the computers should be able to uh, enable either or disable the interrupts as required or as desired. The problem of infinite loop occurs due to successive interruption of active interrupt request signal. So three mechanisms to solve the infinite loop problem. If multiple devices are simultaneously requesting or certain situation which may cause the infinite loop, that is a continuous execution, right? Continuously the same interrupt will be interrupt request will be asserted continuously. That is what called as infinite loop. To overcome them, overcome the situation, we have three mechanism. One is processor should ignore the interrupt until execution of first instruction of the ISR, interrupt service routine. The processor should automatically disable the interrupt before starting the execution. Of course, this is must. Processor has a special INTR line for which interrupt handling circuit. So there are multiple ways to deal with this. You will understand that because handling of multiple devices, that is what the next topic is. We'll see that topic in the next session. So what happens is we can have the, instead of having a common line, a processor can have a dedicated line from each and every device. uh, that is possible. Okay, that is one way to deal. And once an interrupt request is received by the processor from any of the device, interrupt request line should be disabled for a while. Because what happens is, if particular interrupt request is being handled by a processor, simultaneously another device is requesting something, then what happens? Processor, uh, either it should perform the first or it should switch to the next one, right? Right. Up to certain level we can expect the parallelism or concurrent job, but certain or some of the jobs will not be handled, cannot be handled simultaneously. In that case, what happens? It will move into the infinite loop. So to avoid that, what it does is, once it receives a signal from any of the devices, simply it will switch to the interrupt service routine. It will start executing the task which is requested by a particular device, and immediately it will turn off the interrupt request line for a while until the service completes. Once the service completed and it is delivered to the requested device, again the line will be activated. Okay. So another important topic, sequence of events involved in handling an interrupt request. So this is the scenario. This is also called a scenario. It's a common scenario where interrupt request is occurred. Okay, device is rising an interrupt. First step, device rises an interrupt request, then processor interrupts the program currently being executed, because a meaning of interrupt is you have to disturb, right? Disturb, create the disturbance, right? If if 20 members are sitting in a classroom and some lecture is going on, okay, some session is going on, and in between one person speaks loudly, then what happens? A normal scenario is the lecturer speaks and students listens, but some student in between he speaks, then what happens? The class will be interrupted. So necessary action will be taken, in the sense the request from the student will be served, isn't it? He or she might be having a doubt. It can be a doubt clearing session later on. Just analyze the scenario and correlate it with the computer organization concepts. So things will be easier for you. Okay. The processor interrupts the program currently being executed because it has recently received the interrupt request from some of the device. Okay, interrupts are disabled. This is what just now we discussed. So interrupt request line will be disabled. Interrupts are disabled by changing the control bits. Okay. um, the action requested by the interrupt is performed by the interrupt service routine. So ISR will does the required job, and interrupts are enabled back. So I interrupt service routine, request line INTR line was deactivated earlier before while performing the uh, execution of the interrupt service routine. Now interrupt service routine is executed, right? Things are delivered, so to the requested device. So what happens immediately what happens, it will reactivate the interrupt request line, so other person can ask the doubt, right? That's it. So next is about the handling of multiple devices. Let us continue our discussion in the next session. Please go through all these topics. If you have any doubt, please ask. Thanks for watching. See you in my next video.